Hello class, this is Mr. Standerson, and in this video we're going to go over the class notes about combustion reactions. And so I want to take you through a few of the highlights about what a combustion reaction is and how to write the products and balance the equation for any combustion reaction. So first of all, when we talk about combustion, this word is, of course, is associated with fire and burning and things like a camp flame or anything that maybe like a gas stove is going to be using combustion reactions. And remember that fire actually is a chemical reaction. What you're seeing with the flame is really a lot of the energy that's released as heat and light. But there are other products too, and we're going to explore what that is in these notes today. The first thing that you should be aware of is that any combustion reaction is using a hydrocarbon. What that is it's a combination of carbons and hydrogens to produce a fuel. And so when we talk about hydrocarbons, we're really talking about the fuel source. It could be gasoline, could be methane, like if you have a gas stove at your house or if you go camping, it could be propane. Any of those are hydrocarbons that can be used as a fuel in a combustion reaction. All right, the other thing that's really key about all combustion reactions is they need oxygen. In order for the reaction to take place, that fuel has to combine with oxygen gas. And that's one reason that increasing the amount of oxygen, like blowing on a campfire or using bellows in a furnace, that actually makes the reaction happen faster because it's allowing more oxygen to interact with the fuel. And the last thing, I talked about it already, but this idea of a hydrocarbon is any compound composed of both carbon and hydrogens. So the wax, the paraffin wax, if you remember from our labs earlier, there was a long chain of carbon and hydrogen connected together. That is the fuel when you're burning a candle because it's that hydrocarbon. All right, so we're going to take a look at a couple of those things. So our first example is going to show that hydrocarbon, C3H8, combining with oxygen, O2 gas, to make carbon dioxide and, surprise, water vapor. Now, every combustion reaction is going to produce some amount of water vapor. The other example is this CH8H18 with oxygen gas makes carbon dioxide and water again. Notice in both of these examples, we're producing the same type of product, carbon dioxide and water. What changes are the coefficients because you have a different number of carbon and hydrogens combining with that oxygen. So that's what we're going to be taking a look at when we predict the products. We're going to be taking a look at how to write this in a way that we can figure out what the correct coefficients are. Now, there is one side effect of combustion, and that is if there is not enough oxygen. So incomplete combustion means that there is not sufficient or not enough oxygen to make the carbon dioxide. And what happens instead is it produces carbon monoxide. Now that's a big deal because carbon monoxide is very poisonous. It's colorless, it's odorless, it's tasteless, but it does cause huge issues for people because it blocks the absorption of oxygen in a hemoglobin. So oxygen normally attaches to hemoglobin cells and that's carried throughout our bodies. But if we ingest carbon monoxide, it's actually way better at attaching to the hemoglobin and it will prevent oxygen from doing so. So basically, you're going to suffocate if you're in an environment that has a lot of carbon monoxide. And that happens pretty frequently, not always to the point of people suffocating, but people do get ill. And this is an example of a hockey rink in 2019 outside of Chicago. They had to close down the whole rink, evacuate people because people were getting sick. They were throwing up. They were feeling light and dizzy, lightheaded and dizzy. And that was because there was a carbon monoxide leak somewhere in the building. Could have been from a furnace, or it actually could even be from the Zamboni. They actually use propane as a fuel, and if they're not getting enough oxygen to burn that, they would produce carbon monoxide as an exhaust gas. So Some of those things are really important. A lot of times people have carbon monoxide detectors in their house. They'll get their furnace checked regularly to prevent any carbon monoxide poisoning. All right, so we're going to talk about how we can predict products with combustion reactions, and I'm going to go through a few of these examples with you and talk through how we identify these coefficients and how this compares to both complete or incomplete combustion as we're going through it. All right, so I'm just going to reset this here. I'm going to walk through this in just a minute. The thing I wanted to point out, and I want you to write down in your notes today, there are two templates for any combustion reaction that we're going to be looking at. The first one is if there's plenty of oxygen gas. The second one is if you have a limited supply of oxygen gas. But the templates are very similar. We're going to take a fuel, in this case a hydrocarbon, plus oxygen gas, there's the O2 diatomic, to produce, in the case of plenty of oxygen, carbon dioxide and water vapor. If it's limited oxygen, we'll still have our fuel, our oxygen gas, but it creates carbon monoxide and water. All right, so when you're looking at the different examples, it will have to tell you if there is enough oxygen or not. If it's insufficient oxygen, it makes carbon monoxide. If there's sufficient or enough oxygen, it always makes carbon dioxide and water. So any product for a combustion is always going to match one of those templates, and they always produce either carbon monoxide or dioxide and water. All right, so knowing that, we can fill in some of these gaps, right? So if they only give you the reactants, in this case the fuel and oxygen gas, we know that the product has to be carbon dioxide plus water. They don't mention anything about the oxygen, so we'll assume that there's enough. Then we can go in and balance these reactions. My tip for you when you're balancing a combustion reaction is to use the big subscripts for carbon and hydrogen first. So in this case, I'm going to balance 7 carbons on both sides and 8 oxygens on the left side. 4 times 2 gives me 8 oxygens on the right side. Now go back and balance your oxygen. So I'm going to count them up on the product side first, and I have to remember that there are 14 from the first compound plus an additional 4 from the second, so that's a total of 18 oxygens. On this side, if I have a coefficient of 9, 9 times 2 gives me 18 oxygens. Now everything is balanced. All right. Similarly, for this next example, we're going to use the same template to find the product of our combustion is carbon dioxide plus water. Now we're going to balance things out. And there's a tip that I want to show you. So we're going to start by balancing normally, and then I'm going to talk through the tip. The first thing to balance is our carbons. So it looks like I have 2 on the left side. I'll make 2 on the right side. And then hydrogens, there's already 2 there. Counting up the oxygen, I'm going to have 4 from the first compound plus 1 to give me a total of 5. But 5 divided by 2 would give me a fraction, and I have to have whole number coefficients. So in order to eliminate that, my one tip for you is to double the coefficient on the fuel. So we started at 1, so let's try 2. 2 times 2 gives me 4 carbons, so I'll put a 4 out in front of this. 2 times 2 gives me 4 hydrogens, so now I'm going to have 2 as my coefficient. That will still give me my 4 hydrogens, so those things balance. Coming back to oxygen, save that for the end, is always a good idea. I'm going to have 8 plus 2 more for a total of 10. All right, now I can divide 10 divided by 2 is going to give me 5. So now I have a completely balanced equation, and my tip for you is to count the oxygens at the end, but also double the coefficient of the fuel if there's a odd number of oxygen on the product side. Okay, last one I want to go through as a as a practice with you is the one with insufficient oxygen. Now, anytime it tells you that, start like you always do with the fuel plus oxygen gas to produce an insufficient oxygen means it's going to make carbon monoxide plus water vapor. That's always present. Okay, now we can go back and balance. So I'm going to say there's one carbon on both sides. Great. I need to put a 2 in front of this for the hydrogens. So there's 4 hydrogens. Now counting the oxygen, I have 1 plus 2 more. So I have a total of 3. I'm going to double this again because I end up with that odd number on the product side. Okay, so doubling this, recount. I have 2 here. 2 times 4 gives me 8, or 4 times 2 will give me 8. And now I'm recounting my oxygen. So I'm going to end up with 2 plus 4 to give me 6. And I need 6 on the other side. A nice coefficient of 3 will do the trick. So now I have 6 on both sides and the equation is completely balanced. All right, last thing, when you're doing combustion reactions is just to make sure you follow the template. If there's lots of oxygen, it makes carbon dioxide and water. Limited amount, it makes carbon monoxide and water. And I want to show you just a quick practice on your combustion reaction practice worksheet from today. When you're going from a word equation, like they're giving you here, just follow exactly what they're telling you, and then you can predict the products based on the oxygen supply. So if it's limited oxygen, it will obviously have carbon monoxide. If you have a lot of oxygen, it will make carbon dioxide. The fuel they tell you here is C8H18 or octane. When heated with limited oxygen, well, it's combusting, so you have to put in the O2. That just tells you that the limited is making carbon monoxide instead of carbon dioxide. Please go through and balance this by adding in the correct coefficients. You can also balance the one here by doing the same. And the last 2 I want you to do on your own, starting from writing out the formulas and then balancing the finished equation. All right, please reach out if you have some questions. Thanks. Have a great day.